for the hour. Good morning or afternoon, everyone, and thanks very much for joining today. I just want to go over a few general housekeeping items to start off with. So firstly, we are going to be recording this session. I think that's going to get sent out afterwards. Secondly, if you could direct any questions during the presentation to the chat window where someone will be monitoring it, but we are going to have a Q&A session at the end. My name is Andrew Kellan. I'm a systems engineer at ClearShark, and I support the NASA, the DOE, and DOI accounts. Prior to my life in cyber, I worked with industrial control systems and did a bit of PLC programming, so I'm quite familiar with the OT landscape. ClearShark is a value-added reseller working primarily in the federal space, and we pick a small number of best-of-breed technologies to work with in order to bring comprehensive cybersecurity solutions to our customers. Two of these technologies are Splunk and Corelight, and I'm joined today by Richard Chidimitri, my counterpart on the Corelight side, and Drew Church on the Splunk side. So today we're going to talk about OT security and the implications these systems can have on the IT networks that we are used to working on. Before we do, I'm going to allow my fellow presenters to introduce themselves. So Chip, we'll start with you.
Thanks, Andrew. So my name is Richard Chidimitri. I go by Chit. I am a senior systems engineer here at Corelight, and I cover DoD, DOE, NASA, and JPL. So I've spent some time as a senior security analyst at Edward Jones, and before that I served 10 years active duty for the United States Navy. While active, I performed exploitation operations for the NSA under tailored access operations. During my time in TAO, I was also a founding member of the 501st Cyber Combat Mission Team, where I was a lead exploitation analyst performing offensive cyber operations. I later transitioned to a defensive role at Joint Forces Headquarters, DODID. There, I was a founding member of the 93rd CPT, where I helped develop the Deployable Mission Support System, a Zeek bro-centric stack used for incident response and threat hunting for 14 Navy CPTs. At 93 CPT, I was also a Navy assessor for US Cybercom 3000 and 4000 level certifications. And that was for both the Army and the Navy CPTs going for full operational capability. And I'll pass it on to Drew.
Thanks, Chet. My name is Drew Church. I am a Splunk consulting solutions engineer, specifically focused around our security business. Before I joined Splunk about 2 years ago, I worked about 10 years for the Department of the Navy, doing a number of things, none of which were at all as interesting as Chit's. But my last job was as a security operations center manager for the Navy's largest command. I spent some time at Fleet Cyber Command, where I was kind of the liaison officer between one of the Navy's largest industrial control systems, right? So I've worked in this IT, OT, and Splunk and wire data and everything inflection point for a number of years now. So looking forward to taking your questions.
All right, great. So just to give you a brief overview of what we're going to look at today, I'm going to discuss the pieces that make up operational technology, just covering some general terminology and where different terms fit in. I'll then move on to the differences that we see in network communications, that we see between OT devices and IT, and then how we can look at securing OT devices, but the difficulties that we have had doing so. After that, I'm going to hand off to my Corelight and Splunk colleagues to discuss in some detail the specific benefits that their technologies bring to the OT security market. All right, let's crack on. So the majority of what we're going to talk about today in OT will fall under the definition of an industrial control system. That itself is a broad term that covers both SCADA systems and distributed control systems. An ICS could be a system used to monitor electrical output across a wide grid. It could be a palletizing system in a food processing plant, rod and reactor monitoring equipment, a nuclear power station. It's a rather broad term. So availability is absolutely paramount in these systems. They are mission critical. We may be dealing with life-saving equipment in many of the cases I just mentioned. Loss of life is a serious factor when we look at the availability of industrial control systems. So SCADA systems are architectures that are spread over large geographical areas. We might be looking at utility transmission systems, whether that's water or electricity. We have a centralized control system that reaches out to several remote locations, each with their own infrastructure that they control. So these remote locations automate processes by themselves, but they communicate back to that centralized location to make high-level decisions or to visualize data that each system is seeing. DCS and SCADA systems are quite similar. The biggest difference is that hardware in use in many cases, SCADA systems distribute the controls through RTUs or remote terminal units in different geographic locations. DCSs are generally confined to a particular site, but they allow humans to control the machinery in the system in close proximity, either through HMIs or human-machine interfaces. The machinery can be controlled similarly between DCS and SCADA, but the machinery controlled, the actual physical devices can be quite similar, but the method used to control them will generally differ. It's either a centralized location or dispersed into each site for SCADA and DCS, respectively. Now, I haven't included it in the graphic here, but IoT does deserve some mention. It's becoming more and more common to see IoT devices in OT environments. Anything from cameras to monitor equipment visually, ultrasonic sensors to detect failing machine parts, thermal imaging systems to detect hotspots in electrical cabinets, all of these for preventative maintenance. Lots of these devices will be connected through the networks that OT systems use and communicate out in the cloud for management, which presents a massive risk directly to our OT systems from the internet. So IoT is not OT, but they can coexist in very close proximity to each other, so it deserves a mention here. Now, the network characteristics, moving on to the difference that we see in the network side of things. With IT devices, we have a fairly comprehensive coverage on the protocols that we see in these networks. HTTP, HTTPS, IMAP, POP3, SSH. I'm not going to list all of the common ones even, since that would take the rest of the hour. But most, and I do say most because we're going to show later how Corelight is different, but most network or IDS or IPS tools are built with the more common IT protocols in mind. And when we start looking at the communications between PLCs and other OT devices, we start seeing very, very different protocols. We start seeing S7 for Siemens devices. We might see Profibus, Azibus, Modbus, protocols that legacy network sensors can't understand and therefore cannot determine if they're malicious or not. So it takes more advanced versions of these network security devices to understand the different communication methods and provide accurate alerting to malicious traffic or non-standard communications. And we're going to discuss a little bit later the deterministic nature of OT traffic, of OT communications. But on top of this, not all of these communications are done over Ethernet. So serial connections between OT devices are fairly commonplace, and that brings in another level of difficulty in gaining visibility into this traffic. And when I say an archaic design logic here, I mean that some of these OT environments have very possibly been designed with no intention of ever connecting them to a wider network. That includes the IT systems in the same physical location and much less to the internet at large. But as I mentioned, we have devices that will be connected to the internet and to wider networks within the environments that we control. And we have incredibly old operating systems in some cases which cannot be patched. So if we have an agent on a Windows 95 device that controls an incredibly important valve that needs to operate in the case of an emergency, but that manufacturer is long gone, it no longer updates said agent, we can't patch to a newer, more secure operating system, we have to accept that risk to ensure the availability of the system and the ability of that valve to actually actuate through software, should we need to do that in an emergency. So the security of devices sometimes can't be done on the endpoint and needs to fall back onto the network. These networks were not designed with connectivity to wider area networks in mind. Bringing us into the security considerations. So the last slide, I did end up talking a bit about the security concerns towards the end there, but to expand on that, there are a few more points to consider. So we're fairly familiar with the triad of confidentiality, integrity, and availability in IT-focused cybersecurity. And generally, trade-offs are made between these three based on numerous factors: the data that's contained within a system, the function of the system, the list goes on. In OT systems, though, as I mentioned, we're very likely dealing with life-saving equipment in these systems, if not certainly mission critical, which means that availability is the absolute top priority in order to ensure the safety of those working on the system and those who rely on it in the case of utility transmission. So why do I bring this up? Regular scanning for vulnerabilities unleashes a massive amount of traffic onto a network. Something like a Nessus scan that isn't dialed all the way back to 0.5. A huge amount of packets hits every device that they can reach. So this may not be an issue for IT devices, servers, laptops, routers, even IoT devices may be better equipped to handle this. But the level of traffic is not what most OT devices are capable of processing. Regular vulnerability scanning knocks these systems offline, and it can endanger critical infrastructure or human lives at the very worst case. Next, the traffic is deterministic. We have a largely automated process in OT. PLCs contain ladder logic that controls I/O. HMIs have largely pre-configured actions that any human operators can take. In comparison, IT networks would be the Wild West. It's totally non-deterministic behavior. It can change at any time. Much more predictable traffic exists in OT networks, which does give us an advantage in seeing abnormal behavior and being able to flag that as possibly malicious. But we should get less false positives here, since in many systems, there won't be a massive amount of change in the ladder logic causing effect to the environment, causing effect to the different traffic that we would see. There's not many environments that I've been in, that I've worked on, where there are several updates to the software in a single day. And as I mentioned before, the patching isn't always possible. Most endpoint protection platforms may not have agents that support the very old operating systems that we see fairly regularly in OT environments. And we can't upgrade those to later, more secure operating systems. So that means that the security needs to fall back on the network, as I mentioned, and we have to be able to identify malicious traffic to and from these endpoints and eliminate those threats as quickly as possible. So understanding the protocols being communicated on the network is essential to being able to do this. With no understanding of OT protocols and no agent supported on the OS of these devices, we are completely blind to whatever threats might be infiltrating OT networks. And with the design that these networks initially had in mind, encryption was not an immediate solution to implement. These would have likely started as completely air-gapped networks, and to access them, we'd have to be on location and either plug into a PLC or into a connected workstation that was itself completely separated from the IT environment. So often we'll see these protocols are communicated in clear text, since the encryption process might have been a bit intensive for the lower powered equipment of the 90s. So that includes usernames and passwords. And this is where advanced network equipment can really come into play. So we're going to discuss Corelight in far more detail very soon, but having network packet brokers to send traffic to the right tools is important. And we can use them to enhance data that we send through metadata generation. And we can also use IPsec tunnels to encrypt the data that is being transmitted between RTUs and PLCs, giving us a bit more security in our OT environments in case someone is present and may not be actively changing anything, but watching, listening, waiting to see these usernames and passwords communicated in clear text. Now to discuss when OT environments have actually become the target of a breach. The first you will most likely have heard of, the target breach. That's a fairly old one now, which is why I'm sure most people will have at least heard of it, but may not be familiar with the exact details. So essentially, credentials were stolen from a third party that had access to the HVAC system in target stores. This was being used for remote monitoring of power consumption and of temperature. This initial foothold into the HVAC devices allowed them to move laterally through the network and upload malware to the point of sale systems across the target enterprise. So this is an example of a data exfiltration attack that was made possible by a lack of network segmentation between those OT boundaries and the IT environment. There's little to no reason that point of sale systems should have been accessible from HVAC and vice versa. And with better monitoring of the OT networks, targets should have been able to pick up on that abnormal traffic and start alerting on it, stopping before millions of credit cards were stolen. The Stuxnet attack is attributed to a worm that specifically targets Siemens PLCs and older Windows operating systems. It's got a PLC rootkit, and it's designed to go after the OT devices that are controlling nuclear centrifuges, with the general target being uranium enrichment being done in Iran. To which point, about 60% of the discovered cases of Stuxnet have been based in Iran. But what it does, it interrogates the devices that are connected to PLCs, and upon finding the right VSDs or variable speed drives, it makes changes to the frequency that they run at and ruins the process of enriching the uranium by changing the speed at which these centrifuges spin. And then the rootkit goes back and hides all trace of them doing so. So this was a very complex piece of malware that would have taken advanced programmers months to make, but it shows that the desire of OT breaches are not always to move through to the IT side and exfiltrate data. It can simply be destruction of property. And a recent executive order called the Cyber Sentry program to enhance the cyber resilience of organizations that own or operate critical infrastructure. So Cyber Sentry uses sensors to monitor the IT and OT networks of participating critical infrastructure partners for cybersecurity threats. Another malicious attack that wasn't really designed to exfiltrate data, one in Florida, actually in February of this year. There was an attack on the water supply of a town called Oldsmar in Florida. So no weaknesses were really exploited here. It was just a password linked to a TeamViewer account on a workstation that was connected to OT devices. So they used this workstation to massively increase the amount of lye that was in the water supply, but they were intercepted by an operator who saw the intrusion and was able to immediately reduce these levels back down to normal. So in this breach, we had numerous violations of what I think should be good cyber hygiene, lack of protection on the endpoint side, weak passwords being used, and TeamViewer being left open. But the correct equipment was in place to detect the abnormal behavior and the abnormal traffic to the OT devices. At the time I was writing this, I don't think there was enough information yet to know if this was by design hack or if it was someone that lucked out and managed to detect the intrusion. But it's a very real possibility that the inability to detect this breach would have led to a loss or at least serious risk to human life. And on that very cheerful note, I'm going to be handing off to my colleagues to discuss the specific benefits of Corelight and Splunk when looking at OT security. So thanks very much.
Thanks, Andrew. So before I dive into kind of the capabilities for what Corelight brings to the table in OT environments, I kind of wanted to give a small background. So Corelight was founded by the inventor of Zeek, Professor Vern Paxson out of Lawrence Berkeley National Laboratories, and also the main contributors to the open source project after completing 22 years of funding by the US National Science Foundation. So approximately I would say about 70% of Zeek contributors work for Corelight, and that Corelight was actually founded to actually continue the open source project in lieu of the NSF. So what's great about the data generated by Corelight is that it's more contextual than NetFlow and approximately about 1% the size of PCAP, depending on the logs that you're looking at. And what's great about that is, it processes all the transactions seen on the network and creates these text-based logs that can be indexed and searched in SIMs like Splunk. So it makes it non-judgmental, right? You don't want to say, yes, I want to get rid of this data or not. It's passive, so it doesn't really interfere with sensitive networks like OT, right? So if you add something inline, you potentially ruin those networks because you have latency or other issues. So a lot of times that also helps because it doesn't tip off attackers what's actually monitoring the network if it's passive. So some unique things about Zeek is that it's extensible, which means that you can actually take existing logs and extend it with extra or less context, meaning that if you want more data, you can add more data. If you want less data, you can take it away as well. And cool things about it is that new protocol parsers can also be created and utilized by the community, which I'll present in the next slide. So the last thing that I'd like to talk about is that it's it kind of empowers the enforceable policy aspects. So if you have networks that are clear cut like OT, you can actually create policies that say, hey, if I see this type of data, let's do an alert check. So it tells you that network traffic did or did not occur on the OT network, and it provides yourself a source of ground truth. And what I mean is that when we talked about Stuxnet before, attackers generally like to cover their tracks. When I was in NSA, that's one of the first things they teach you is that hide in plain sight, live off the land, make sure that whatever you did is not traceable by a defender. So researchers have been using this type of tooling in OT environments for many years. And in fact, back in 2016, a university in Sweden and researchers in Sweden wrote a really nice white paper called Exploiting Bro for Intrusion Detections in SCADA Systems. So I want to talk about the out-of-the-box, ICS SCADA protocols that are covered by Corelight. So the two that are main pieces that come directly in Corelight, are Modbus and DNP3. There are also 5 Amazon parsers that are built into the Corelight package manager that include BACnet, which is the building automation and control, which actually was used in the breach and target. ENIP, which is Ethernet over IP, and Profinet, which was actually made by Profibus, and then S7 Comms, which is a Siemens proprietary protocol, and then tabular data streams. But tabular data streams is not strictly an ICS protocol. It actually is a Microsoft protocol. And what's interesting is that it's actually used by SCADA historians. So data that's coming from the SCADA network actually goes to a historian, and you can actually monitor it as it's transitioning through the network. For CISA, there's actually 4 CISA protocol parsers, 2 which are similar to the ones that I mentioned by Amazon, which are BACnet and ENIP. But CISA also created parsers for the Bristol Standard Asynchronous Synchronous Protocol, also known as BSAP. And they also covered it over serial and over IP, as mentioned by Andrew earlier. And then Ethernet for Control Automation Technology, also known as EtherCAT. So they've also done 2 extensions of the main logs inside of Corelight for Modbus and DNP3, and that extensibility adds things that are not in the base log itself. And both of these packages can be found on the package manager at zeek.org. So I want to talk about what if those protocol parsers that I've mentioned before are not included. Well, there's actually a new project that is being headed by Corelight called Spicy. So Spicy was originally developed as a research prototype at ICSI, the International Computer Science Institute, with funding from the US National Science Foundation. So since the creation and inception of it, it's been actually rebuilt from the ground up by Corelight, especially one of our founders, Robin Summers, and it's actually been contributed back to the Zeek project. So what makes Spicy kind of unique is that it's simpler than BinPAC. It's a parser generator that makes it easy to create robust C++ parsers for networking protocols, file formats, and more things. What is interesting about it is that Spicy is a bit like a YAC, which is yet another compiler for protocols. But it's much more than that. It's an all-in-one system that enables the developers to write attributed grammar that describes both syntax and semantics of input formats used in a single unified language. Kind of think of Spicy as a domain-specific scripting language for all your parsing needs. What's great is that Spicy actually comes with a Zeek plugin that enables adding new protocols and file analyzers to Zeek without having to use any C++ code. So you define the grammar, specify which Zeek events to generate, which is the logging outputs, and then Spicy takes care of the rest. There are also Zeek analyzer packages that provide Zeek with several new Spicy-based analyzers. And you can actually test it out at zeek.org and see the information of how to install it. So this is a very simple diagram of how Corelight is actually deployed and instrumented on the network. So if you connect your Corelight sensor to a tap span or packet broker, it could be a physical sensor, it could be a Corelight software sensor for lightweight usability, or if you have virtual environments, a virtual sensor. You can IP it, set your security policies up, pick core packages and any of the OT protocols that I mentioned, or Corelight custom content like C2, which is the command and control information, or encrypted traffic collections for anything that you see potentially encrypted on that side of the network. Or you can actually use your own custom scripts and parsers, like I mentioned before with Spicy. And then once you've set that up, you can set the exporters to Splunk and done. So Corelight is compatible with many industry tools. We are pretty much using standard ways of exporting, including to Splunk. So we use Splunk's universal forwarder, as well as the Splunk HTTP event collector. So you're allowed to send the Corelight data to multiple tools simultaneously, and that includes using batch exports for long-term storage on an SFTP server, or to an S3 blob storage in the cloud, or even on-premise like Minio. All that takes is enabling the Splunk exporter. And what you do is you create a simple outputs.conf file on your deployment server, and you just point the Corelight sensor there. Once it's done, it just sends the data. So depending on complexity, a Corelight sensor can actually be configured and sending data into Splunk in as little as 15 minutes, excluding cabling and racking and everything else. We're also Common Information Model compliant, which means that we feed into a lot of the Splunk security data models, including Enterprise for Security. So you can also download our TAN app from Splunk Base, and that's pretty much it. I'll give it off to Drew now.
Hey, Chit, thanks so much for walking us through what Corelight brings to OT specialists and their IT counterparts. I've been working with the author of the TA to make sure that SIM compliance is so important. And why SIM compliance is important really does feed around how Splunk operates and how we do that schema at read search to scale across all these IT and OT data sources. And part of what those data models do, right, are provide that scalability and that standard taxonomy, right? So regardless of whatever protocol, when we're looking at IP-based traffic, right, we're able to say, no matter the log, hey, we're always going to look at IPs in the same field names, regardless of whatever the data source is coming on. And so I want to slightly shift and talk about one of the cool things that I don't think that we've really ever talked enough about, and that happens to be the OT security add-on. This add-on was debuted in the summer of 2020, and it builds on top of that core data analytics capability with Splunk, and on top of that market-leading SIM and enterprise security, right? When you think about the coverage and the domain specialties across OT and IT specialists, there's kind of a gap, right, where you have your security operations focused on SIM, and you've got your OT specialists focused on lower level things. The OT security helps with Corelight with other data sources, really brings together all of that into a single common work surface. We're able to really make sure that we have kind of a technology agnostic look across that facility or group of facilities. Kind of highlighting these three things, right? That unified data model. So one of the things about Splunk and about enterprise security and OT security on top of it is the concept of assets and identities. And when we think about OT, like OT assets really are like in more ways than IT assets, right? OT assets are more like those pets, not cattle, if you're familiar with that kind of transition as we look and stop caring about like the name of a server, for example, right? OT assets are tangible things, and Andrew really kind of hit on that earlier, right? So being able to understand the context around what that asset is critically important, right? Being able to say, hey, where in the world is it? What does it do? Is it an HMI? Is it something else? Is it one of those other sensors that we talked about, right? And then we're able to bring across that analytics across everything, and we can bridge, you can read on the slide yourself, but we can bridge all of that data across multiple different domains and multiple different views in that same set of data. Another thing that the OT security add-on brings in is detection capability, right? And so inside of enterprise security, inside of traditional SIM, you have alerts. We call them correlation search and notable events in enterprise security. What the OT security add-on brings is pre-built correlation rules for ICS protocols based on the MITRE ICS attack framework. Another thing that's important, especially when you start thinking about compliance, is NERC SIP, right? Understanding like what those interfaces and reports are, and able to help report on the audit and compliance requirements that you all know much better than I do. So that was kind of our focus for the first version of the add-on, again, in summer of 2020. Let's go ahead and take a look at the latest major release just a little while ago. So again, kind of focused on additional ICS attack detections, and this focused more on additional partner capabilities to include Corelight, and as well as additional reporting and dashboarding around NERC SIP. I think slightly more interesting, right, is that kind of the event typing and how we're able to bring that integration with different alerts, like, for example, the Zeek alerts into something a little bit broader. And then also focusing on turning those alerts and that data into kind of the security orchestration automation response, or SOAR, platform that we have in Phantom, and able to, we have workbooks and playbooks that help make all of those integrations work significantly better together. And when you kind of like back up for a second, you ask like, what's important here? It's all the work that you do is essentially impossible without data, right? When you're trying to defend these things, when you're trying to protect them, when you're trying to improve that security or even operate them, right? You have to understand and have that visibility. And personally, my favorite data source has to be wire data, and that's why I loved getting to come and talk to you all about this with Corelight, right? Like that's like wire data at scale and speed in a passive way, I think is so important, right? When we think about the machines and the assets and everything that you all work with on a daily basis, keeping everything safe. If we all go back to our like information security certification exams, I remember when I was taking my CISSP, right? Like the instructor getting us ready for the exam said, you know, if you're looking at a question, you're asking, what do you need to do and how do you implement these controls? Like, and you're looking at this question and you can't figure out which of the two of them is the right answer. Which one's safer? Which one is going to keep people safe? Which one's going to make sure that everyone goes home safely at the end of the day? That's the right answer. And so when we think about how we're going to implement security controls in our environments, like I really do appreciate that the ability to gather this data like out of band and at that passive way so that we're not interrupting these streams and making sure that everything's able to work correctly. Let's take a look at a couple screenshots of what the OT security add-on looks like. As I mentioned before, within the OT security add-ons, there's dozens of different dashboards, reports, and searches to bring context to that wire or other sets of data that you're collecting from your systems and sensors. On this specific page here, we're looking at the Asset Investigator page. Up top, I've gone ahead and searched for a specific SCADA device, and we start to understand where it fits within the environment, what machine IDs, maybe who made the device. You can see here it says HP, what the priority of the component is, right? And so understanding, hey, is this something that's critical or not? And then using that to inform risk. And then important, especially in the OT spaces, like where in the world, or in some of your cases, where not in the world is it at this moment? Looking below, you can see some metrics related to the behavior of the specific asset selected, right? For example, the number of hosts it's communicating with, and like whatever delta is there, right? Because that can indicate either positive or negative behavior from both an availability and a security perspective, as well as some other network traffic focused details like the number of sessions and ports accessed, right? As we start thinking about maybe some of those threat vectors that Andrew talked about, hey, we can use this wire data as what from the alerting perspective coming in from like a Zeek package or whatever, but also bringing, hey, maybe there's just like the con.log where we're starting to look and saying, hey, what kind of traffic is there, and starting looking at different ways that, and that's where Splunk really brings some value to that data. If we were going through a live demo here, we could scroll down a bit and we'd see some compelling visualizations like a session traffic analysis map where we visualize in real time a diagram of like the different hosts and devices that particular OT asset is interacting with. Right, we've all looked at our like network diagrams. We've all looked at what we think is going on in the real world. But when you actually are starting to see and sniff that traffic, you can say, hey, what is it actually talking to? And either say, okay, that's not supposed to be happening. And I know because this is supposed to be this device only talks to that device and that's it. And there's very good reasons for that. And you start seeing it's talking to 5 devices, right? You have that single source of truth in the wire data. I think you've all seen the signs that say, you know, PCAPR, it didn't happen. and I think Corelight brings that to you. Going one more screenshot, let's take a look at the an example dashboard for NERC SIP content. SIP 005 is showing analytics about the electronic security perimeter, ESP. And if you dig into the underlying requirements for NERC SIP, right, you're looking at the different zones and facilities, and we can bring that all there, or we can filter it down and say, hey, I care about this today, or I want to dig into this zone or this particular facility, and then pivot across time periods to do your investigations. Like, for example, on 005, there are statements like require multi-factor authentication for all interactive remote access sessions. And then there's a further on requirement to make sure that you have methods to determine active vendor remote access sessions, right? When you think about that Florida treatment plant and you think about what's going on, right? Do you have the data? Do you have the sensors? Do you have the ability to actually see what's going on, right? It's fantastic to have the alerting, to have that data, but are you getting notified about it? Are you able to go look at it? Is it easy to see? Does everyone have to be an OT like expert to understand what's going on here? Or can you bring context? Can you bring visualizations to that data stream to make it valuable for everybody and help federate out that experience? When I was on the general schedule side of the house, as a GS federal employee, it was very simple for me to say, we've got multi-factor authentication enabled, yep, and we've got logs, absolutely, to somebody coming in and assessing me, right? Absolutely, like, yep, I can show you that I have a CAC right here, and I'm using that CAC to log into this workstation. But when the assessor would say something like, show me, right? Show me that you have those logs, that you're looking at that. That was always kind of a cringe moment, if you will, and just say, hey, like, yeah, I've got that, and I can look at my stuff, but I don't have a holistic picture of what's going on. And that's some of the power that Splunk, particularly the OT security add-on, brings to us. Really, the sky's the limit here, and we bring an out-of-the-box capability in the OT security add-on, but when you start contextualizing with all the other sources of data, and you're like asset databases, firewalls, other endpoint monitoring technologies, within that, it really brings out the power of what you have going on there, right? And then I do want to dive deep a little bit into how this all works under the hood. I mentioned before that the OT security add-on uses an asset data model. Can we go to the next slide for me? Thank you so much. I kind of want to unpack that OT asset data model and explain why OT and IT data can live kind of harmoniously in that single platform at scale. Those data models are part of that framework that Splunk uses to normalize data during search. And I kind of talked a little about this, but I want to kind of show you in the slide what we've got going on here. Right. So we're doing this during search and not during ingestion. Why that matters is you're not dropping data to the floor. So when we take two separate data sources like Corelight for wire data and Microsoft Sysmon for endpoints, both technologies have the capability to output logs that show network traffic. Right, so we've got the con.log from Corelight or open source Zeek, and then you've got event code 3 for Sysmon. Corelight will give that data in that JSON or tab separated value log files, and Sysmon will provide it in XML formatted Windows event logs. During the onboarding process in Splunk, we use what are called technology add-ons or TAs. Those TAs tell Splunk what the fields in the data mean and provide capability to map that data back to these data models. So kind of what does this mean? Right, when you're looking and trying to hunt through the data, you're building searches, you're building reports and dashboards. Rather than making a huge series of like a Boolean like OR in that data stream, you can search against that data model and say when you're saying I want to look at when all the source IPs look like something, you're using the same field and letting us at Splunk in the platform handle that for you. Why do I think this matters so much? Is it really goes back to the professionals and the people involved in these processes on the OT and IT side of the house. They can speak the same language. Maybe they're looking at different data sets, but you can increase knowledge sharing. You're able to make sure that everyone's doing things the same way. And then because of the power of the platform and the scalability there, those data models return these questions that you're asking it in milliseconds versus minutes, hours, when you're trying to build out these complex queries that aren't going to quite get you there. And when you kind of think about those dashboards that we looked at here just a few minutes ago, right, they don't care what the data is coming from, right? You didn't see, you know, right? We're talking on a webinar, we're talking about Corelight wire data, but you didn't see a brand there, and there's kind of a reason for that, right? Because when you're doing this, like we're in the middle of that, and it's like vendor agnostic, and so that means when you add Corelight, and you know, you heard Chit say it, you know, 15 minutes to get that data in the system, right? You're bringing that data into the platform and you're getting value out of it much, much, much more quickly rather than having to retrain analysts, retrain all these things. You're able to onboard that data and continue improving. And when you add additional data sources, maybe it's an endpoint solution, right? You can start taking advantage right away and minimally, like it's ready to go. The detections from the OT security add-on from an ICS perspective are there. The dashboards are now taking advantage of that now that you've got Sysmon on the Windows endpoints, right, to help monitor, right? You have it all ready to go, and the dashboards start populating, right, rather than have to go through that. So I'm really impressed with what Corelight's been able to bring to the table, especially in an OT perspective, understanding those traffic flows, understanding those custom protocols, like being able to bring in those packages. The work that's going on with Spicy, it's super cool to see. I particularly like there's an open VPN detection that came out recently, right? When we're starting looking at those encrypted traffic strings, like, and start being able to detect outliers in behavior and things that we weren't able to do, and do it like faster than we've ever been able to do it before. It's just a huge, huge benefit to the security community. And that's about all I have for the team today. Do we have questions to go through?
Yes, we do have one question. Splunk has the Stream app. How does Corelight differ from what Stream does?
Fantastic question. I'm going to answer from the Stream side of the house. I'm going to say what Stream is, and then maybe Chit, you want to talk about what Corelight does, and we'll see if we be in the middle there. So the Stream app is kind of the Splunk out-of-the-box way to get wire data into Splunk. It's very, the idea is, right, you're sitting on you can install it locally on any of the supported endpoints like a Windows box, a Linux host, whatever it happens to be, or using the independent stream forwarder and saying like on a promiscuous or span port. And we've got the ability to pull streams off the wire. It's configurable via a UI. And then again, now you just got a bunch of data in the platform. It's all SIM normalized, and that's fantastic. But there's gaps in that, right? And we have only so many protocols under the hood. There's some constraints about how that all works together. It's a fantastic way to get started with using wire data in your environment. But if a customer said to me, "Hey, I'm really embracing and I'm looking down the path of I want to bring wire data into my environment," and they were actually serious about this, I would absolutely say, "Let's talk to Chit."
Thanks, Drew. I really appreciate that. So from the Corelight side, the kind of difference is that Corelight is actually extensible, and I mentioned it before. You can actually create new protocol parsers to fill in those gaps. So it can come from yourself developing it. It can come from Corelight as we do research ourselves, and it can come from the open source community, like we saw with CISA and Amazon, actively giving back to the open source community via the package manager. The other thing you could do is, you could use the scripting language also to actually identify abnormal behavior. So if you wanted to, you could look at some behavioral stuff. One of the cool ones that I've seen lately was from Lexi Brent, who actually was looking at some of the NSA leak tool sets. And what's interesting is that based off of the scripting language, she was able to identify how some of these, pieces of malware and exploits were being used from the internal suite of tools to traverse networks. It kind of honed in on some of the MITRE attack framework, lateral movement kind of pieces. And so being able to actually hone in and identify those things accurately was very key. The last thing I wanted to mention too is kind of the data outputs. So when you look at Corelight data as compared to Stream, we actually have something called a unique identifier. It's related to the flow. So just imagine that your flow has multiple different protocols being used. We actually identify and separate those protocols into each individual layer 7 logs, but then you can actually use that to pivot between, information. I hope that helps answer that question as well.
That's a great point, Chit. And I think that unique identifier, there is a fantastic not a white paper, a cheat sheet that Corelight put together to help trace the different logs together. Somebody hold me to it, and I want to make sure that we get that out to the participants as part of the wrap up when we send out the recording, because I think being able to understand and trace that data is phenomenally important, and we do it at scale in Splunk. So it's exciting, and I think you hit on all the key points. I think Stream is great. I think it can solve a number of different problems quickly, but definitely if you're ready to do this at an enterprise scale, I think most of our security professionals here at Splunk would definitely lean in and say Corelight's the answer there.
I'd also add in there, it's a good way of getting started, technically for free. It's a free app, but it obviously creates a lot of traffic. The log formats that are brought in by the Stream app count towards a discounted license for a lot of customers, but when you start looking at doing this at a large scale and you've seen the value that wire data can bring in, you want to start looking at more protocols perhaps that aren't supported by the Stream app. Corelight can then take you that extra step further, but the log formats that come from Corelight are also part of that discounted license as well. Just wanted to add that in.
That's a great point, Andrew. Thank you for clarifying that. I think we have another question, and I'm just going to read it out loud for anybody that can't see them. Does the OT security add-on require Splunk Enterprise Security, or will it work with standard Splunk Enterprise? The answer is it requires and is an addition. It is a free add-on for the Splunk Enterprise Security add-on. So it is essentially augmenting and extending what we have in enterprise security, leveraging the frameworks like the asset and identities framework. It's leveraging the notable event and correlation search frameworks to add those capabilities, but it adds kind of an OT lens on top of it. Great question. Are there any other questions? Love to answer them. I'm not seeing any. Andrew, Chit, anything you guys want to add up before we close it down?
I think we covered things pretty well. Thanks everyone for tuning in. All right, I think we're good to wrap up. I'm seeing people dropping off. Thanks everyone for your time today. We'll make sure that the recording sent out, as well as the extra documents that Drew was mentioning earlier. Thanks very much.
Thank you so much.
Yeah, thanks Drew. Thanks Chip.
Thanks, Andrew. Thanks, Drew.